I left on everyone's desk this. We're gonna go slow today. We're gonna go slow today. And what I want to start with is, what are we doing and why are we doing this? This isn't just sitting around doing geometry lessons. This is surveying. So what are we doing? When we talk about traverses, last week we looked at a property survey, right? We looked at the plat of survey that might have had something where we know a bounded area. And what did we say when we talked about this last week? We said this is how we define property. This is how we came up with that this lot 65 is 7,365 square feet. This is a traverse. It's a four-sided traverse. A traverse is a bounded area in this case. It's a closed traverse. So each of those bearings relates to a measurement. All of the lengths relate to a measurement, and it defines this box is what it's doing. It's defining an area. That's what we're doing. We'll be working with traverses, and that's the ultimate goal, is how do we define what an area is? Because we mentioned this last week. This is how we know what we own. This is how we do a plat of survey, and we define, if I own parcel 1340, that's my property. And in any court of law, any type of property law, it's defined by that area, those bearings, and the property corners that are there. So that's kind of where we're at. So we are going to now learn the process of how do we calculate that area, how do we calculate the sides, the bearings and the azimuths. How do we do that? Now the reason we're doing that also is for this. One of the end goals, and we worked with the instruments a little bit. I still got to get Manny and Yvette. We still got to get you guys behind it. We'll do that today. What did we learn so far of those that have worked on the instrument? If I set the instrument here, we're a little small here. What did we say? Is it called zero set? We can zero set a line on the instrument. We learned how to do that last week, right? If I set on point A, and I sent Gabe over here with the prism at point E, and he sat on point E, and we knew that this is where we wanted to start. Just picture yourself out in a cornfield somewhere that we're gonna do this traverse. This is our zero line. That's where we're gonna start. What can I do once I set zero with the instrument? I can turn this angle, right? I can turn this angle, and the instrument will tell me what it is. What else can I do? I can send Gabe over to this point at point B, and what can I do with the instrument? I can measure this distance, right? So we have the ability to set on a point, to get a baseline, to turn an angle, and to get a distance between that. Does everybody kind of get the concept? And Yvette, Manny, you guys okay? Just following that? Yeah. After we do that, we can go around this shape. So I can pick up a second set. I can take the instrument and I can move it over here and I can set it on point B. And I can do that same iterative process where I backside on A, I zero set this line, this is my baseline, I come over here and I shoot this and I turn another angle. That's the process of surveying a traverse. Set on a point, measure an angle and a distance. Set on a point, get a zero set, turn and measure a distance. That's what we're doing. That's what a traverse is. So by doing this process, we're going to have angles. So let's say this. What did we do? We got an interior angle here when we did that shot. You guys okay with that? We came over here. We're going to get this interior angle. And we can do that 3 more times. And we can find all 5 of the interior angles. Because we have the distance measuring capability of the instrument, we can measure these 5 distances. We've now run a traverse. That's what running a traverse would be. We set up and we go around the shape. Now, what have we learned in 10 weeks of this class about errors? Lots of things happens, right? We're human. Lots of things can happen. The temperature, the distance. Maybe I didn't set on the point right. Maybe the instrument's out of calibration. Maybe all sorts of things. So the likelihood of us going around this shape, taking 5 measurements, distances, and 5 angles, and coming out exactly perfect are probably pretty slim. If we did, we're probably more lucky than we are good. That's how it's working out. So our job is then going to be able to determine, how do we calculate, how do we massage, how do we adjust the traverse given all of our numbers and all of our angles so that it mathematically is 100% perfect. That's the process of what we're going to kind of go through today, is learning how to work with the traverse. So we're going to be dealing with the shape. Derek?
So like one of our first problems we did, basically there's the same thing.
Mm-hmm.
So we figured out the difference and then we added it to each leg.
Yes.
But what if your angle was off?
Correct. Derek is talking about that 8.2. I got it right here. I think we worked this problem that first week where we said, let's add all 5 of these up inside of the traverse. We came up with something that was not perfect, right? 539, 50, it was short. It should have been what?
540.
Should have been 540. So we had this little gap. This was our difference. We just kind of last week, just arbitrarily in the homework, said, well, what if I balanced this? I averaged this out over these 5 to get the shape right. That's what Derek was kind of asking. In the case of a traverse, what's different is, and this was just what? A shape with 5 angles. What didn't this have? This didn't have distance. So if we just had a simple geometric shape and needed to balance the angles, we could average it out and do that. But what's our difference with this is we have lengths that we've got to factor in now too. So we may not add up to 540, but the distances could also be off too, right? Prism pole could be shaken, could be a hot or a cold day, could be temperature, the prism was broken. So we may have adjustments that we need to make in the distances as well too. That's what complicates. That's what complicates it, but we have a means of simply working through that. So, that answer your question?
Yes.
Okay. So I handed out to you 2 things. I handed out this kind of shape, and let's just look at kind of what's a couple of factors that we have on here. What did we say when we talk about latitudes? Latitude sounds like what? Ladder, and ladders are what? Up and downs. If you look on this shape, we're going to have 2 terms that we're going to be working with. We're going to be working with latitudes, and we're going to be working with what's called departures. So latitude, ladder, up and down. Departure, think about a plane on a runway. Departure's taking off, it's going horizontally on a runway. This is how we are going to work with this point A to point B. And what we're going to do in the traverse is we are going to basically try to create a big box. If we can create a shape around this box and we can look at these different lengths, we can determine where we're off. That's basically what it does. Let's look at something here. We know if we go from point A to point B to point C, what did we do in the departure distance? We basically started at this point and we horizontally went to here, and we horizontally went to here. We've pretty much made it across the shape from here to here. Do you guys kind of see how that works? So if I had this departure and I added them together, it's the distance it took me to get from here to the far side of the traverse. Does everybody see that? And I know I'm going slow and we're kind of, but we can get to that side. Now what happens if we come the other direction? If I was to take this and this and this, these 3 distances, what did I get back to? I got back to where I started, right? So I've essentially said, if I could determine what this departure is and this departure is, I can get to one side. If I can come back the other way and get this departure, and this departure, I can now see this to this, it should be the same, right? If it's not the same, we know that somehow when we took all 5 of these shots and turns, something happened. Doesn't mean we didn't make a mistake, it's just that it didn't balance out in the left and right direction. Does everybody kind of see that? This is principle. It's just the principle of what we're doing. Let's go in the other direction. Let's go the latitude. Let's go latitude, ladder, up and down. So if I started at A and I went up to get to B, that's the highest point, let's say in the shape that I'm at. Let's bring it back down. I come back down, I take my latitude here, I get my latitude to D, I've now come all the way down. If I come to here and I take the latitude up and up, I get to the same point, right? So we are going to now calculate this length and this length, this length, this length, and this length, and we're going to see if they come to 0. We're going to do the same thing in the up and down direction. We're going to calculate these 5 latitudes and see if they add up to 0. So we can then find out, do I have a problem in this direction? Also, do I have a problem in this direction? Then how do we balance it? It's going back to what Derek asked. This kind of deal is just a shape with just angles. That's all this is just angles. This is now a shape with angles and distances. You guys kind of see the concept? This is conceptual. That's how we're just trying to think at this point. It's just conceptual. That we want to determine all of these different latitudes, and departures back and forth. So that's going to be our goal. So let's take a look at one aspect of this. What do we see, and what have we been dealing with for 8 weeks here? I've got what? To do this, I got to watch my colors here. So, what do I have when I look at this triangle? It's a right triangle, right? Mm-hmm. So our friend sine and cosine, right? Our friend sine and cosine. So if I happen to be able to determine that angle, and I knew what that was, I could use sine and cosine, right? If we shot this distance, and this happened to be, look on your other sheet, 164.95. I got a distance for the triangle, right? I handed you guys this out, right? You guys got the other sheet? Grab the other sheet, because we'll start working. We're going to start looking at some numbers. Then we can actually look at some numbers here. And I'll go back and forth. And if I start to lose anybody, oops, I want you to yell at me real loud and say, Bob, you're losing me. Because I realize this can probably get a little dry. But think of it as a puzzle. Just think of this as just all we're working on is a puzzle. Let's take a look at our shape. So we're going to put some numbers to this. If I was to take, and you guys go ahead and just follow along with me. If I was to look at this triangle, we've got some numbers, right? We've got a distance of that triangle. But what also do we have? I just dotted this in. Let's say we've got a bearing in this direction of north 71 east 11. What does that mean? Where is that angle? That angle is what? That angle is this, right? Because it's a bearing. It's north, and it's tipping 71 degrees 11 minutes to the east. So we know that this angle here is 71 degrees 11 minutes. And within the traverse, when we did all of our shots, and that's what this is the result of our shots. We measured 1, 2, 3, 4, 5 angles, and we've got 5 distances. So our goal is to try to determine what the departure and latitude is for this line. So how can we do that? Sine and cosine, right? Sine and cosine. So everybody's going to look at that triangle a little different. But we know that we have an angle here and an angle here. And we know that we can use sine and cosine. I'll put my table on. To be able to accomplish that. So what do I know about this angle? If I was to say 71, what side is this? Is my latitude my sine or my cosine of the triangle? Here, I'm going to stop talking for a second. I just want you to stare at this triangle a little bit. If we needed to find this latitude and we needed to find this departure, here's what I'm going to do. I'm going to stop talking for a second. I'm going to let you use the angle that you know to determine what you think the latitude and the departure is. And we are dealing with sines and cosines. All right, let's ask this. For the latitude, would you be using the sine or the cosine? Who thinks for the latitude we'd be using cosine of that angle? Or does anybody know? Everyone's staring at the paper going, holy floppy, I have no idea. It's okay. It's all right. So let's go back to our triangles. Cosine is what? It's the hypotenuse over the near side, right? So if we said our latitude's going to be our cosine there. And if I said I knew what the cosine of 71 degrees 11 minutes was, and I could multiply that by the length, would that give it to me? So let's go here. Start using your calculators. This is going to be, so 7111. Go ahead and make the conversion to decimal. 7111. So what do you get? I get 71. I'm going to write it here. 71.1833.
Yep.
1833 degrees. Oh, did I? I'm sorry. Thanks, man. So the cosine of this times the length, 64.95. Run that out, what do you get? 164.
163.
I get 53 feet, 53.20.
53.4.
53.20. I want to make sure everyone punches that up and can get it. $53.20. Give me a shake of the head if calculators that you got it. Because this is that, I know I put this out in the announcement last week, getting your calculator to be able to get you from degrees in minutes and seconds to decimals quickly. Use the calculator. You don't have to do it longhand anymore. All right, give me a shake of the head if you got it. Manny, yes? I'm just kidding. See that? Maybe that's what I got to do. Manny, what do you see? Not getting it?
I got 0.32 for the cosine 71 degrees 11.
Okay, so cosine of 71.1833, and Manny took the cosine of that. You get 0.3225.
Yeah.
So let's just go up here, 0.3225. Manny, I agree with you. So let's multiply that by 164.95. See what you get. That should be 53.20. Sam, you all right? You got it? Logan, good? Gabby? Crystal, you got it? Yep. Shakes the heads. Bri, you got it? Gabe?
Yeah.
Liking it? Okay. So this is now the distance that we went due north. That's what this is. It's the distance we went due north from point A to this top line of B. So departure. Let's do the same process, but departure is going to be what? Departure is going to be the sine. We're going to use the sine of the angle. So if I was to say up here, 164.95 feet times the sine of 71 degrees 11 minutes, which what we already converted to 71.1833. Throw that in your calculator. Tell me what you get.
156.13.
156.13, Derek says. 156.13 feet. Shakes of heads. Yes?
Yeah.
I see shakes. All right, that's good. So going through that process, we've now determined what the latitude is for A to B and what the departure is from A to B. Now, Bob, why do I care about that? This allows us to get this first leg of the traverse. We can now get from here to here to determine how did we do on that distance. Do the same thing with our latitude. So let's go to the next setup. What did we do on our next setup? Go ahead and take your shape and let's go ahead and let's extend, because now we want to find out how far horizontally and how far vertically did we go from B to C. All right, now we got to do some creative thinking. We've got a couple of angles, don't we? Now you gotta let this marinate a little bit, because this is the little piece of complication. There's a couple of ways, because what are we missing right now? What do we got to find? We need this. We need an angle, don't we? It gave us this. We got a bearing here. We've got this interior angle. But what do we really need? We need this, don't we? We need that. So we know there's an angle here. We know inside of this angle there's a 102.11. What's this outside angle? This is what's called, and what we kind of have to work on a little bit here, is we've got to kind of dissect this. This is where this whole axis concept of using an axis at our point comes into. First and foremost, can everybody kind of see how I set this up? I got a north axis going through the B. I got this east axis going this direction. We want to look and try to find out how we can determine this. So what are some things we know? Let's just go back to, I'm going to do this real fast. I think we talked about this in maybe week, it's 11, maybe week 9. Early concept. And I have this. What do I know about this plus this? Sam says it equals 1A. Does everybody agree?
Mm-hmm.
Yep. So A, B equals A plus B. If I use this concept, I can find any angle along an axis. Chris, was that a hand up or just a? Okay. So if I look at this, just look at this as a puzzle right now. What pieces do I know? I know I've got 102.11 on the inside of this. I don't know what this is. Do I know what this is? Or could I calculate? Could I find what that is?
You could.
I could, right? What do I know about this plus this?
That should be the,
This is a 90. A triangle's 180 degrees, right? This angle plus this angle in a right triangle would be what? 90 degrees, right? So this angle right here, this small one, is what? It's going to be 90 degrees minus 71.11, right? Does everybody see how I came to that? For this triangle here, if I wanted to find this angle, it's going to be 90 degrees minus that. Which is what? How would we do that? Use your calculator to do that. You've got 71.11 in, you can put it in decimal, you can use your calculator in degrees, minutes, and seconds, however you want to do it. What would that angle end up being?
18.8167.
18, so let's say this. So I hear it in decimals. So out here I'm going to say it's 18.8167, right? What is that in degrees and minutes? 18 degrees and what, 49 minutes? 49 minutes? So that equals that. All right, now we got something, right? We now know that this little angle in here is 18 degrees, 49 minutes. We've got this 102.11. So what is this? It's what? It's 180, right?
Minus 18.
It's 180. And we got to take both of these away. It's minus 18 degrees 49 minutes. And it's also minus that 102 degrees 11 minutes. So if you solve for that, what do you get? I know what I got. See what you guys get. All right, Derek's got an answer. Who else has an answer? 59. I got a couple 59. 59 and no minutes. 59 degrees. 59 degrees.
Kangaroo on there.
0 minutes.
Shot overrun.
So 59 degrees, 0 minutes. Everybody okay with that? We're just dissecting, and that's really what we're doing is we're setting up an axis. We're using whatever they gave us to find what we need. So now that we know the 59,
Figure the other.
we can do the same thing as we did over here, because we're going to have a latitude here, and we're going to have a departure, right? Departure like a plane down the runway, latitude like a ladder up and down. Here's what I can tell you. For this latitude, we're going to use the cosine function. And for this departure, we're going to use the sine function. So let's go ahead and punch this up. What do we have? We've got the distance here, 8841. What's the departure? So departure is going to be the sine function of the angle. So it's going to be 88.41 times the sine of 59 degrees.
45.
Sine. 75,
Oh, I did it.
So 88. We got any numbers for the departure using the sine function? What do we got? 59 sine times 88. 75, 78, Manny?
Yeah.
70, that's what I say. 75.78 feet. So that's going to be the departure going down the runway. How about the latitude is going to be the ladder, the cosine. So do the same thing. 8841 times the cosine of 59. It's 45.53. Yep. Getting the hang of it now, right? All right, ready to start making it a little easier?
Yeah.
Let's start making it a little easier. That method of calculation is how we're going to work our way around the traverse. So what I just handed you is a table. Tables are good for spreadsheets. Tables are good for Excel. Tables, eventually, you just plug numbers in and things come out. But what did we say about spreadsheets? You don't use a spreadsheet unless you know where the formulas came from, right? So we're building a table so that we understand where the numbers came from. So let's do this. I'm going to show you how to set the table up to kind of make the calculations a little simpler. So let's do this. Here's what I'd like you to do. This table, let's go through what's on here. There's some criteria in here that you don't know yet, and that's okay. We're going to get there. But we're just going to start kind of with the left side of the table. Let's look at what we have in here. So station is just going to be our point. A course is what? Course would be the path of travel. So a course might be A to B. We're going to have a distance on the table, and then we're going to either have a bearing or an azimuth. So we're going to be able to use that angle. Now you're going to notice in here, latitude is what? Latitude is north. So latitude is ladders, right? And the departures east to west. So let's just do this. We've got this shape that's got an A, a B, a C, a D, and an E. So here's what I want you to do. In your table, let's set this up. Just jot these in the boxes. A, B, C, D, E. And go ahead and add A on the bottom. Because we're going to use this table to help guide us in what we're going to do by balancing the traverse. That's what this is for. So our course is just these points. So A to B, this is B to C, C to D, D to E, and E to A. So that's our travel path. That's the 2 points that we're going to work with. So distance. You can go ahead and just on the traverse, let's fill in the distances between A and B. So A and B is 164.95. You guys can just fill those in off of the example problem that we're working on there, 41 feet. And then that next column is bearing or azimuth. So we're in the process of calculating these individual bearings. So we know that right now, this bearing of the first one is what? North. It's going to be north, 71 degrees, 11 minutes, east, right? And here's just a little tip. What is it in decimals? Just what is the azimuth in decimals? So how about this? What is the azimuth of this 7111? What quadrant is A to B in? We're going from point A to, oops, sorry about that. We're going from point A to point B.
Northeast.
We're going to the northeast. Grab your cheat sheet. What does it say when we have a bearing and an azimuth in the northeast quadrant? What is it? The bearing is the same as the azimuth, right? So our azimuth is going to be 71 degrees, 11 minutes, AZ. And here's one more other thing we can put in that to make our sine and cosines easy. What is 7111 in decimals? We already calculated that, right? It's 71.1833. 1833 degrees. There we go. So we have all the information that we need. We have our distance. We know what a bearing, we know what an azimuth, and we've even got it in the azimuth in decimals. Now check out the table. What did we do in that first series of calculations? We said to get the latitude, we use this one. Latitude's ladder up and down. We use the cosine function. Look here. The table that I've got has cosine right in it. It tells you what to do. The table is going to tell you what you have to do.
Wow.
So the calculation that we're going to run out on this thing is just using the angle, 71.833. It's just what we did here. Take the cosine of it and multiply it by the distance. And we did that already, right? We got 53.20. And we did it for, oh, I'm sorry. You guys, I'm sorry about that. So I'll hit that again. So cosine's already in the table. We have our angle. We're just going to take the cosine times the distance. Let's do, and the sine, we said what? We calculated that at 156. 0.13. So let's go to course B to C, which was the next one. Now let's take a look at what's here in our triangle. Now we got to start thinking about our angles. What we want to do is know its bearing or its azimuth. Bearing or an azimuth. So from B to C, we calculated all three angles. Let's think about the homework from last week. What is the bearing? What's the bearing? Yep, we're gonna be going to the south and east. So we can already say the bearing. Let's just say south and east, because we're south tipping to the east. How do we find the bearing? What would the bearing of this be? What do we know? We know we've got 59 degrees, but is 59 the bearing?
No.
No. Why is it not the bearing? What do we need when we do a bearing? What we have to start on the north-south axis, right? So do we have to subtract? What will we subtract to get this angle here? 90? Well, we could do 90, right? We could say 90 degrees minus 59 would give us that angle, right? So this is really 90 degrees minus 59.
Oh, 31.
31? So 31 degrees, 0 minutes. And that's our bearing angle, right? South tipping to the east by 31 degrees, 0 minutes. Does everybody see that? That's like last week's homework. Kind of. We're working with this angle here. Is everybody okay with that? Yeah? What's its azimuth? What's its azimuth?
180 minus 31.
180 minus 31. What do you get when you do that? 149? So here's what we're going to do. That is our azimuth, right? If we were to say that this 149 minutes is our azimuth. And you'll see I put forward. So this is the forward azimuth. Our azimuth is from B to C. It's 149 degrees, and we got that by tipping from this north axis all the way to here. And we did it by taking 180 minus the bearing, because that was what was in the cheat sheet. Are we okay with that? I'm gonna hold and let everyone kind of just digest a little bit here.
Yeah. Can you zoom in a little more, please?
Absolutely.
Thank
Yep.
So I found this one. Be the same, right? 180 minus 31.
So there's a lot going on that sheet, right? You just kind of have to digest 90s and 180s and just subtracting from the puzzle to find what you can find. Don't let it overcomplicate it. Just think of it as turning angles. That's all that we're doing.
Why is it forward azimuth?
Why is it a forward azimuth? From B to C, this is going to be called, what we're saying is in the forward direction. So we're going to be in the forward direction. If you guys look on that other sheet, you guys will notice the direction of travel.
Oh,
Direction of travel. In this case, when we went out and we shot this traverse, we went in the clockwise direction of travel. So this would mean that from an azimuth standpoint, A to B is the forward. We went this way. B to C, we went forward. And that's what defines an azimuth. It's the direction. So B to C is currently our forward direction. What if we went from C to B? If that would be a back azimuth. So you're going to hear that. We're going to use that. We're going to get it even simpler. I'm going to tell you, we're making this a little complicated so that you can see all the ingredients to this. it's gonna get even easier. But we want to dissect these. Bri, you got a question there?
Oh, wait, I just got a little lost.
Okay.
How did we get the 149 or the 149 on Cofes?
The 149 here.
Yeah.
Okay, 149 we got from here, Bri. Let's say this. We know that this is what? From there to there is what? 90 degrees, right?
Yeah, 90 degrees.
90 degrees there. And we went another 59 degrees. So this really came from 90.
Oh, so instead of subtracting to find the angle,
You can do it two different ways, right? And this is, again, you may look at this a little different. 90 plus 59 would give you 149. Or we can use the crib sheet that says if I have the bearing says 180 minus the bearing is, will give you the same number. Yep,
The
Derek.
way I did it, when we were figuring out that triangle,
Mm-hmm.
the last one, I basically found my 31 degrees because that was the last angle.
Okay.
And then obviously if you continue on B to C line, that's a straight line. So it's 180 minus 31, which will give you
Yep.
149.
We'll give you 149. Yep, you could do it that way too. Yeah, we're going through this process right now. And the book talks about this. If you want, just jot a page number down real quick. The book shows us on page 183. 183. So if Bob's explanation needs you to hit the refresh button later on, the book is going to do the same thing. So you can always follow along in the book here. They had the 102.11, the 71.11. They calculated that azimuth as 149 here. Same. They're getting at it a different. We're all coming at it a little different. But that's basically what this is we're just trying to solve the angles that are in that traverse. All right, so let's do this. I'm gonna set everyone off on a course. Here's what I want you to do. See if you can calculate this bearing. What do we know from C to D? What's the bearing going to end up being? What's our letters? We're going what direction? South.
Southwest.
So we're going south. Let's go ahead and fill that in. And west. We know that. We got a distance. We know that from C to D, we're going to get what? A forward azimuth. Forward azimuth is going to be going in that direction. I'm going to let everyone kind of, let's do this. Calculate, see if you can calculate the bearing. And maybe I'll kind of get things started here a little bit. Because once you start drawing triangles and lines and axes, you start to see things. Maybe by me just adding, I'm going to add some arrows. So maybe you'll see something in some of those angles that might kind of help you. What's this? All right, let me ask this. If we know this angle, what's this angle?
Same.
Same, right? Do we agree?
Mhm.
Same. So that might be a little help. if I have, I know what this is in this triangle, right? What is this? 59? 59 degrees, 0 minutes. What's this?
31, oh,
Should be 90.
Okay, right, 31, does everybody see that? It's 90 degrees minus that. 31. All right, so, and I already know it gave me this, right? 104.42.
my drawing sucks, but.
It's okay. You know, look, I've been had to teach this for a few times, so that's why making big axes and big lines and using colors and stuff. It's your first time there. That's why I say it's all part of the process of just. So this is going south and west, right? And we're looking for the angle from C to D.
31 on the right.
C to D. Say it again, Brian.
On the, your first, so yeah, you know how you got the 31 degree right there?
Uh-huh.
Wouldn't it go on the other, like, I forgot, because it's congruent, right?
Yes.
Whatever you say it, it's 31 on that side as well.
It is correct.
You would subtract 90 for the other side?
You could look at this one, Bri, and see that 31 degrees and maybe see a pattern that you could use for that.
Oh, it's 31.
You would do,
34.3.
so you do 104 plus 31, and then you take 180 away from the sum of that.
I like it. You guys kind of seeing? I'm letting you guys kind of all work through. Yeah. 31, 104, 42.
Should be 44.3.
How are we doing? So yeah, has anyone got a number here? What are we thinking this is?
44.3 degrees.
0.3 or are we working in degrees minute? No, I don't want to mess anybody up here.
18 minutes. I think. To figure out our lat and our departure, we can use decimal, right? And then when we get our
Okay.
azimuth,
Yeah, how about this? We'll do this real quick here. I'm gonna punch this up, so minus 104. And minus. So, I'm hearing 4418. Do you like that number? 4418. So if this was 44 degrees, 18 minutes, liking it? Everybody okay to kind of get there? Andy? Is that an emphatic yeah? Like, yeah, Bob, I got it. Or, hey, Bob just called on me and I think I kind of got it.
I haven't gotten to that point, but is it going to be 90 degrees minus 31?
You're gonna, how about this? Let me try a different color here. I'll try to highlight it a little bit. What if I was to say this, Manny? I have got this blue line right here as my axis,
Okay.
it's 31 degrees.
and I've got
Straight
this,
line, so
yeah,
that's 180.
31 here.
180 minus this, minus
and
this,
I've got this
into that.
104 here.
Okay.
So I've got this and this. I'm looking to fill this in. So if I was to say this whole thing is 180 degrees,
Oh, so you just subtract 31 and 104.
you got it.
So
Yep.
is that 104.42, 104.7?
In decimal? Is that what you got in decimal?
Yeah.
Yeah, if anyone converted to 104, that sounds right. 104 something?
104.7.
104.7?
Yeah.
Yeah, yep. And then with the 31, converted back, 4418. So, what is this? This is right? South tipping west? So we found the bearing of 44, 18. So we got it.